Hi everyone, and welcome to today's Chemistry Daily Booster, number 10 in our series and another advanced information listed topic. Again, only explicitly listed on the higher tier, but that doesn't mean that things won't come up on the foundation. What we're going to be looking at today then are half equations first of all. Now, half equations are something we need to get our head around as far as how we can write these things. They're likely to come up in questions on electrolysis, for example. That's one of their kind of favourite half equation questions. What half equations do is they actually show us what happens to one reactant in a chemical reaction. So rather than looking at the whole thing, we're only going to focus in on one of those reactants and see what happens to it. If we look at an example here then, okay, so this is our example, sodium reacting with chlorine to make sodium chloride. So what we're going to see, first of all, we're going to write the half equation for sodium. So we're going to focus on just one of those reactants, in this case, sodium. So when we read it, sodium reacts with chlorine to make sodium chloride. So we're going from an atom of sodium to an ionic compound of sodium chloride. We know it's an ionic compound because we've got a metal joining to a non-metal. Because of that, we are going to start with a sodium atom and we're going to make our sodium ion, Na+. Because it's a positive ion, that means it loses an electron. Only the one, because it's only a single positive charge because it's in group 1. So when we write the half equation, we literally write down the formula for sodium. There's an atom, Na, and then we're going to say what happens to make the sodium ions. First of all, write the formula for the sodium ion, Na+, and then we've got to add our little symbol for the electron, because from the atom what's happened is an electron has been lost. So Na+ and an electron, E-. And that's it. That's the half equation for sodium. If we do the other side now, focusing on our chlorine making sodium chloride, then again we start with chlorine atoms. They're going to gain an electron to become chloride ions. So chlorine is in group 7. Remember what we said in a previous booster, that means they are diatomic. We must have Cl2. If you don't have the 2, your half equation is wrong. So Cl2, and we are then going to gain, it says an electron, but that's an electron per chlorine atom. We have 2. So that means we've got to have 2 electrons, and that's going to make 2 chloride ions, Cl-. That's literally what half equation is. You start off by writing down what we start with, the atom usually, and then we are going to add or remove those electrons in order to make the ions. But we only focus on one reactant at any point because we're only writing half equation, not the full thing. The next step is understanding what we mean by ionic equations. So if we think about a complete ionic equation, that shows the ions present in a reaction mixture. But it also has the formula of molecular substances or those that are found in the solid state. So that's what we mean by a complete ionic equation. If we start off with our little example at the top, okay, so we've got hydrochloric acid reacting with sodium hydroxide to make sodium chloride and water. Now, to write out our complete ionic equation, then we're literally splitting these into any individual ions that are present. But you only do that with ionic substances, okay? So, what we start off with, hydrochloric acid, that is an ionic substance, so therefore we have hydrogen ions, H+, and chloride ions, Cl-. So this little first section here is our hydrochloric acid. The next bit, we've got sodium hydroxide. It's ionic again. So we have sodium, Na+ ions, and hydroxide. Remember, it's a compound ion, it stays together, OH-. If we then consider the right-hand side, we have sodium chloride, NaCl, ionic. Therefore, we have Na+ and Cl- ions. And then finally, we've got water, H2O. Now that is a molecular substance, therefore it stays as H2O. We don't split that up. What we then do is we need to identify things called spectator ions. Now, spectator ions are ones that basically stay the same. So what you'll do is once you've written out your full ionic equation there, you'll identify them because they are exactly the same on the left as the right. So if we look at this, we can see that we start off with H plus on the left, but we don't have H plus on the right, not a spectator. Cl minus on the left, we have Cl minus on the right. So that is a spectator ion. So we're actually going to ignore it. Na plus on the left, Na plus on the right, it's a spectator. We're going to be ignoring it. OH on the left, but not on the right. So not a spectator. That leaves us with just the non-spectator ions. So spectator ions are ones that remain the same on the left as the right, and we've crossed them out. That then leads us to be able to write the net ionic equation, which quite simply is the one where we've left out those spectator ions. So we had the hydrogen ion, the hydroxide ion, and we had molecular water. So all we do is H plus OH minus makes H2O. And that is the net ionic equation. You will quite often see these net ionic equations used in precipitation reactions, and sometimes they can literally use that example there of the hydrogen ions joined to hydroxide to make water. So watch out for that one in multiple choice questions as an example of an ionic equation. Last thing to do today then is head on over and have a go at the quiz to check your understanding of today's work. Obviously, if there are bits you're still not 100% certain on, take the time to go over it using your own notes, the videos on the main channel, revision guides that you may have, just to make sure you are confident in it. Because higher tier, this is one of the bits that could very well come up because this section is listed on the advanced information list. Don't forget to join us again tomorrow for our next Chemistry Daily Booster.